Right, we're going to look at residuals that go with linear regression. And so what we're basically going to do is we're going to look at a set of data, and then we're going to ask ourselves, could I use a linear line to represent the data? So let's go ahead and start with a piece of data here. So here's some table that I'm going to pull from a Google Sheet. I'm going to paste this right into Google Drive. Into Desmos. And just remember that you need to use Control V when you plug, when you paste it in, because you won't be able to right-click it. And so what you can see here is here's a list of points, it's just a table X, Y, and then they plotted the points. So I'm going to go ahead and use linear regression. Linear regression, if you remember, is just, could I draw a line that represents the data, kind of a trend line, right down the middle of the data. And so the computer's going to do that for me. And so remembering that I have to use the same notation, right? So I can't use Y's on what I'm going to use. I have to use Y sub 1s. And so I'm going to type in y equals mx plus b, with the tilde here and the subnotes, so the computer can read that I'm referencing that particular data. And so this is linear regression. So it drew this line right down the middle, best it could, to represent how the data is behaving. So there's a couple of ways I can figure out is how good is that line? Is that line a predictor? Because every set of data, I could draw a line through it, but the question is, how good is it? So the first indicator that I have is my R-score. Okay? So this is a positively sloped line, so my R-score is positive, and it's 0.78, and that's a pretty good correlation. The closer we are to 1, the better the correlation. The closer we are to 0, the worse the correlation is. But what we want to focus on now is the residuals. And so the residuals is a measure of distance from the line. So, for example, if I look at my first piece of data, the residual is going to measure how far above that point is from the line. The next piece of the residual is going to measure how far this one is from that line, how far that one is for that line, and then it's going to plot it for me here on the x-axis. So I'm going to go ahead and do that. I'm going to hit for residuals. I'm going to plot it. Okay. So I'm going to go ahead and turn this other stuff off here for a second. Okay, so the residual is always given over the x-axis, and it's a measure of how far the data is from that trend line that I tried to create. So if you look at it, here's the line again. All right, so the first piece of data, okay, this one right here, this piece of data, if I go back to the residual, is this far above that line that I created using linear regression. The next piece of data was this far below it. The next piece of data was this far above it, right, and down. So when I look at the residuals, when I look at the plot here, it's another indicator of how good of an indicator is that line that I created. How good is that line? That's the residuals are going to help me figure that out. So there's a couple of things that I'm looking for. I would like to have about half the data above and below the x-axis, saying that when I drew that residual in there, when I drew that linear line in there, I wanted it to be about halfway between the data, half the data above it, half data below it. And this particular set of data, when I look at its residuals, gives me about that, right? I got, 3 pieces of data below it, 4 pieces above it. That's pretty close to half. So this is a pretty good indicator that line, this line right here that I drew through that data, is a pretty good indicator of how the data is behaving. Okay. So when I look at the residuals, there's a couple of things that I want to be aware of. Okay. So the first thing is I like about half the stuff on top, half the stuff on bottom, like I just said, and that is about true. And I want no pattern. I want randomness with that 50-50 relationship. So let's look at another set of data. Okay, so kind of looking back at what I just said, we have an R-score as an indicator of how good that line fits, as well as the relationship with the residuals. So what I'm going to go ahead and do is I'm going to pull another set of data here, and we're going to look at this residuals and see how it compares. Okay. So now, if you look here, I have to make sure that this is x sub 2 and y sub 2, so if I want to use this same equation, I got to change these to sub 2's so that it will reference the data. Okay, so here is the data, or the green points here. Okay, this is the linear regression that I just created using this formula up here. And if you look, it cut the data in half. About half of it is above and below, so that's why it picked that line. So I'm going to come over here and see if that's what I'm looking for. So if I look at my R-score, it's 0.2. That's closer to 0 than it is to 1, so that means it's a pretty weak correlation there. So that's not a good indicator that this set of data can be modeled linearly with a straight line. So then I'm going to go ahead and plot the residuals and turn this other stuff off so I can just look at the residuals. So here's the residuals, okay? And what I told you in the last example was, hey, if half the data is on top, half the data is on bottom, that's a good indicator that this residual is telling me it's linear. Well, that's true in this case. However, there's a pattern to it. The fact that I have this pattern, you see as I'm kind of tracing it, tells me, okay, this is not a good set of data to be modeled with a linear line because there's a pattern. Even though half's on top, half's on the bottom, there is another function that could model this. And if you could tell, possibly just by looking at the data, a quadratic would probably model this function better. And that's what we're basically looking at. Is a straight line the best tool? And that is definitely not true. Okay. So let's look at one more set of data here and look at another situation that can occur. Okay, so I'm going to shut this off. I'm going to paste this last one in. And look at it, it defaulted to sub 3s here, so I'm going to change that so it'll reference that data. And so now when I draw in the line, you go, you know what, hey, that doesn't look too bad. All right, so looking at my R-score, it's 0.79. That's a pretty good R-score. So I'm thinking, hey, you know what, this data looks pretty good. So now for my kind of reassurance here, I'm going to double check and look at my residuals. Okay, so let me turn off this other stuff so I can just look at the residuals. And you go, hey, you know what? It looks random to me. About half on top, half on the bottom. That looks good. But there's a bit of an issue here. If I come back over here and look at the table, now this is only true because they're in order. You see how they go all positive, then all negative, and then back to positive? That's kind of hard to see here in the residuals on the graph, but in the table, there's a pattern here. There's a pattern, and so that's telling me, you know what, this is not going to be modeled very well with a linear equation. The R-score is misleading me, okay? And that's why I like to have the residuals as well as the R-score, because I see this pattern here, and that tells me, okay, you know what, a linear line looked like it was going to model it, but it's probably not going to do that. And so if I go back to my data here, turn off the residuals, okay, and if you look at it, it's kind of hard to see, but the issue here is, if you want to know why it's kind of misleading, is this would be modeled really well with something like a exponential. You can see here, how this look kind of has this look to the data. So if I was to shift that over a little bit, I could show that so I got to put in some parentheses here, that I could kind of go, oh yeah, look, this is much more represented by an exponential function. So the R-score can be a little bit misleading sometimes. So we want to look at the residuals as well as the R-score.